Welcome back, my dear friends. A very good morning, good afternoon, good evening to all of you wherever you are in this part of the world. And as you know, this is the second lecture in the first week for the DADM3, which is data analysis and decision making. And the main idea of this course is to basically cover the techniques and operation research, all the gamut which I mentioned. And as you know, this course would be for 12 weeks, 60 lectures of total duration. If you count them up, add them up, is 30 hours. And after each week, we will be in each week we will cover 5 lectures. After each lecture, each week of lectures will basically have one assignment, such that we will basically have 12 assignments, and considering the 12 assignments at the end of the whole course, we will have a final examination. Now, if you remember, I was basically considering the assumptions of linear programming, and I will giving you a feedback. So, basically they were the properties and the assumptions. So, that slide I I was not able to cover in the last few minutes of lecture 1. So, I will again reiterate that and basically further continue the discussion of linear programming. So, properties are basically, as I mentioned, are the properties of the linear programming, which are inherently there, and based on that we assume some assumptions. And if you remember, I had mentioned the assumptions of the Newton's law, I mentioned the assumption of pendulum, simple harmonic motion of the pendulum, we do away with friction, we do away with the radiation of heat loss, whatever it is. And we get results in the theoretical sense which are closer to practicality, and they give us a good idea. So, linear programming is basically a technique based on which we can get some idea. It is basically a tool, and we are going to learn the different type of mathematical techniques of the tool. And if you remember, I did mention in the first class that linear programming also has a lot of philosophical way how you model the problem. Obviously, that has to be taught, that has to be inculcated, that has to be brought up and seeped inside you through experience. So, I will try to give some examples in different flavors, they would be picked up, but I will keep it minimum. Both would be from the point of view of 2 dimension one and the actual problem formulation what we use. Now, I will come to the property assumptions in linear programming. So, the first assumption is certainty. If you remember that I mentioned that certainty basically means the decision variables, the input parameters whatever are certain, that means they do not have any distribution, they are not probabilistic. This assumption would be basically done away with as we basically go into the area of stochastic programming, as we go into the area of robust optimization, as we go into the area of reliability optimization. So, we relax that, but for the linear programming very simplistically we will assume the property of certainty for all the decision variables and the parameters. We will also consider the concept of proportionality, that means the proportionally the decision variables can be broken down into in minutest part as possible. But now remember here, this may not be possible in the practical sense. Say for example, I am trying to basically produce some kgs or liters, kgs of some quantity, may be for say for example, for fertilizer, may be for some feed to be utilized for cattle, and in liters it can be the paints which are being produced, in liters output can be the pollutants. Another example, if you remember, I mentioned about the trucks being transported. So, if you are traveling the total distance and you want to minimize the distance, minimize the cost, the distance travel can be to the minus possible distance. It can be in kilometers, it can be in deciliter, decameters, it can be centimeters, it can be millimeters. So, the distance can be found out accordingly depending on the problem. But now consider the problem is basically trying to utilize the minimum number of trucks. So, the trucks technically can be 2 or 3 or 4 or 5. So, technically they cannot be 2.3 number of trucks. So, we will consider the proportionality concept to be there, and this would definitely be utilized as a precursor when we consider the concept of this integer programming. Integer programming means when you are trying to solve and find out the number of trucks for this problem. So, we will consider them to be not true in the case for the linear programming, where proportionality would basically be utilized. We will also consider the proportional, means the proportion in which the can be increased or decreased. Additivity we will basically consider in such a way that any addition or subtraction or addition of more products for the decision variable, more products for the parameters, more products basically for different constraints which are there, they can be added and subtracted in the same proportions considering the linearity holds. So, say for example, if you are trying to produce 10 liters of one paint, it can be, if it is goes to 20. So, the additivity would basically hold in the sense that the total amount of raw materials which we will try to utilize for producing that paint would be added up in the same way as you have done, and proportionality would basically hold. Divisibility, which I just mentioned, there was a switching between the proportionality and divisibility. Divisibility would basically mean the decision variables can be divided to the minusest possible way, so as that finding of the results can give you the actual decision variables to the decimal points, to the fractional point, to whatever level it is required, and proportionality would basically, coming back to that proportionality factor, the proportionality increase and decrease of the decision variables of the parameters would be considered accordingly. We will come to that as we solve the problems accordingly. In the linear programming also, we will consider initially the decision variables are non-negative. So, obviously, non-negativity would mean that we would not produce negative of some chairs. So, it will be either 0 or positive. So, it can be 1 chair, 2 chair, 3 chair, 4 chair. Say for example, if you are a carpenter, if you are trying to produce liters, so it cannot be any negative liters. So, negative liters would not hold true. So, it can be basically 0 liters of production of paint 1 or 1 liters of production of paint 1 or 2 liters production of paint 1, depending on the problem which you are facing. If you are trying to basically transport goods in a truck, it can be, say for example, 1 truck or no truck or 2 trucks, 3 trucks, 4 trucks, whatever it is. So, the concept would be that we will consider the problems in the sense that the decision variables would be 0 or any positive number, negatives would not be there, but obviously we will, when we formulate the problems later on for different type of supply chain management data, we can see that this concept can be brought down in the area of with negative variables also, and we will solve it accordingly, but give the flavor of that. So, these 5 basic technical requirements or assumptions of certainty, proportionality, additivity, divisibility, non-negative variables will be the crux of the assumption based on we will solve the problems, and the properties have already been discussed in the last few minutes of the first lecture, and also I briefly mentioned in the beginning of this second lecture. So, these would be the 4 basic technical requirements for properties and 5 different assumptions based on which we will simply try to basically solve the problem for the linear programming as such. So, considering the basic assumptions on linear programming, so there was the properties and the assumptions. So, basically let us go into the depth of what we mean by the assumptions. So, first let certainty exist. So, if certainty exists, as I had mentioned, that means it means that the variables which are there, decision variable parameters which are there in the objective functions and the constants are known with certainty. That means the values may not be known, but they are known that if I find out the result as 3 number of trucks, it will be 3. It cannot be, say for example, any other different value, because if the if non-deterministic concept was there, obviously the numbers, even if you find out, can vary depending on what is the variability of the dispersion. If you are saying that we are going to produce, say for example, 3.5 thousand liters of paint 1, it would obviously mean that the values which are produced are sacrosanct, such that any deviations would not come into the picture, because the decision variables are non-probabilistic. So, second would basically be the proportionality concept, which will be there in the objective function and the constants which I have already mentioned. So, the proportional increase and decrease would be considered for both the objective function and the constants, depending on the variables which I found out. So, obviously, if you remember, there are different alternatives. So, if there are different alternatives, they would be different levels of decision variables. If there are different levels of decision variables, it would mean the proportionality concept would be there both for the constraints as well as for the objective function, in order to basically keep in mind that that assumptions would be important in order to solve the problem. To give a very simple example, I will consider, obviously they can be done in the problem, but we will initially not consider that. Say for example, I am selling 100 items, consider them items as some numbers, and if I say for example send 200 of them, obviously somebody would basically demand a reduction in the prices, some rebate would be given to me. So, initially we would not consider the rebate or the reduction in the prices, because we will consider the assumption such that it will be easy for us to basically discuss the problem as it is required. The third additivity concept would be that the total number of activities which are there, activities means what we are trying to do in order to achieve our objective function, would basically be the sum of the individual activities required together. So, it basically we are trying to produce chairs, manufacture chairs, we are in a position to manufacture tables, we are producing some paint, we are giving some services to the customers who are coming to the bank, we are giving some services to the people who are there in the tailor machine counter or in the counter where they are booking the tickets or getting the refund in an airline industry, or in say for example in the railway counter. We will consider that if individually they do the work, the total sum of them would basically be equal to the sum of all the individuals together, and this will come up in the discussion. So, if you are trying to understand what these assumptions mean, they would basically come out in the discussions when we solve the problems or give very simple examples. Fourth, which we have said is that let divisibility be possible or should be there, which would imply that the solutions, as I said, can be in fractional values. Even though I did mention time and again and I did warn you that if you are trying to find out the problem solutions for the number of trucks, obviously divisibility is not possible, but we will still stick to that. Based on the fact, we will try to utilize the concept of linear programming in order to solve the concept of integer programming concept. But in the general sense, we will consider the divisibility is there. And finally, all the answers of the variables would be non-negative, because the quantity of the physical goods produced or the number of persons who are working or the number of machines which are being utilized, whatever the decision variables are on the number of hours you are trying to utilize, they cannot be less than 0. So, we will consider them all to be non-negative and proceed accordingly. Now, to basically what we have discussed is basically the overall general feel of what we mean by linear programming. So, now I will basically go into the concept of general historical perspective of linear programming, or it is nothing to do any theoretical concept, but I will just mention few names. And remember, these are the forefathers for linear programming concept or optimization concept, and later on we will also check different people who have been there in the area of nonlinear programming, in the area of robust programming, in the area of reliability programming, or so on and so forth, and we will discuss them as we proceed. So, now again I am mentioning I may not be able to mention, or I may skip, or inadvertently or carelessly I may skip some of the names. So, it does not mean other people are not famous. So, this is just as I was reading or whatever information I have, I am just trying to give you a feel that who are the famous researchers who are basically considered as the forefathers or the fathers of this area of operation research. So, the first person is Kantrovich, who was born in 1912 on 19 January, and he died on 7th April 1986. He was a Soviet mathematician and an economist also. He has worked in the theory of the development of optimum allocation of resources to find out the best possible combination. He is basically considered as the father of linear programming, and he was also awarded the Nobel Memorial Prize in Economics. So, obviously, this economic prize does not come from the Nobel Foundation, it comes from the bank, and he was awarded the Nobel Prize in Economics in 1975, and he was also given the Stalin Prize in 1979. So, the link which is given here, the fourth bullet point, and the sources of Wikipedia, you can basically read it and try to understand who was this person, and it definitely will inculcate some interest that why operation research is very important and being utilized in very big way in different of the areas of resource allocation, supply chain management, marketing, in finance, in behavioral science and so on and so forth. It is definitely utilized in a very big way in engineering fields of electrical engineering, in mechanical engineering and all these areas. The second person about whom I am going to mention is by the name of Kolmogorov. So, people who are from the area of statistics definitely must have heard the name of Kolmogorov inequality and his different type of famous proofs which have been proposed by Kolmogorov. He was also a Soviet mathematician. He was born on 25th April 1903 and he died in 20th October 1987. He made significant contribution in the area of mathematics of probability theory and topology, because if I consider statistics basically, and from a very simple point of view, I will basically divide into the area of probability and other would basically be of statistics. So, he is considered a very stalwart in the area of probability theory. He has worked in the area of topology, turbulences, classical mechanics and trying to build up algorithms and information technology and computation complexity. So, any information about him, if you are interested, just click the name in Google or in Yahoo, wherever you are comfortable with, and just do try to get some information about this gentleman by the name of Andrei Nikolaevich Kolmogorov from Russia. He was also a pioneering area whose ideas and proponents and different concepts were utilized in operational research, are utilized and based on which the operational research field has been built up. The third person about whom I am going to talk is basically John von Neumann, and many of the people who are there in the game theoretic concept who study game theory know that von Neumann was considered the one of the fathers of game theory, and his classical work in game theory. Obviously, later on Nash came, but game theory and the concept of game theory and how it can be utilized mathematically with mathematical derivation has been proposed by von Neumann and other group and a person. So, John von Neumann was an Hungarian and American mathematician, a physicist, and he was a computer scientist, and he was considered a polymath. So, basically during World War he migrated to USA and basically settled there. Von Neumann was generally regarded as the foremost mathematician of his time and is said to be the last representative of the great mathematicians and is considered a genius. So, he was born in 28 December 1903 in Budapest and died in 8 February 1957 in USA. So, sources about von Neumann can definitely be searched in the Wikipedia, and definitely you can go through. They may not be exhaustive, but that definitely they would give you some idea and who these persons were, why they are famous, what based on what work their concepts, their ideas had been utilized in operational research. Obviously, their effect is there in different areas, but I am just taking their names because I found them to be very interesting. Work had been done in the area of operational research. Now, another person whose name would be occurring time and again is by the name of George Bernard Danzig. So, Danzig has two classical books. If you these books have not been mentioned in the reference list. So, he has two classical books in the area of linear programming and non-linear programming. So, they are available in India in the paperback edition by Indian publishers, but generally the classical books were there published by the foreign publishers. So, he was born in 8 November 1914 and he died in 13th May 2005. So, his Danzig's work in linear programming especially in simplex methods is considered the basically the framework based on which all this progress has been made. So, he was an American mathematician scientist who made contribution in industrial engineering and the application of OR in industrial engineering, in operational research, computer science, economics and statistics. He is known for his development of the simplest algorithm, as I told, an algorithm for solving the linear programming concept and how you proceed to find out the solution. So, the concept based on which you proceed conceptually is very simple. So, how you proceed, we will consider that later on when we solve initially the simplest graphical method and then go into the later for trying to solve the problem. And he is also known for his other work with linear programming concept. So, you can find out about him as mentioned in the Wikipedia link of George Bernard Danzig. From the economics point of view, many work had been done. So, all these obviously all of them are a mathematician, but Charles Koopmans, who was a Dutch American scientist. So, he worked in the area of concept of resource allocation from the economics point of view. So, resource allocation may be, say for example, you have different type of goods and you want to basically give different type of benefits to the society, or maybe say for example, you have different nutrients, your amount of money which you want to basically utilize for purchasing these nutrients is limited and you want to give the maximum nutrients or maximum calorific value to the kids who are in the hospital. So, how will you basically manage that? Or you have different goods to supply from one part of the other country to the other part of the country and you want to transport the maximum amount of goods, try to utilize the least number of trucks, try to basically traverse the least amount of distance, because traveling the least amount of distance, utilizing the minimum number of trucks would basically reduce your cost, but at the same time you want to basically increase the benefit of what you are trying to transport. So, these areas are very interesting in economics, and Koopmans is considering the pioneering figure who had worked on these areas and used different mathematical models. So, he was born in 20th August 1910 and he died in 26th February 1985. He was a Dutch American mathematician and economist. He was the joint winner of the KANPUR-NPTEL prize along with KANPUR for the 1975 Nobel Memorial Prize in Economics. As I said, that this prize is given by the Bank of Sweden for his work in the area of optimum allocation of resources and how they can be basically optimized in order to maximize or minimize your objective function, whatever it is. So, information about Koopmans can be found out in the following link. So, the links may not be visible to you, or if you do not worry about that, just go to Google, just go to Yahoo or Alta Vista, just type it and find out the links and study it. So, it will give you some motivation and it is rather than only studies, it will also give you a background that how these people have worked out in the areas of operation research. Obviously, I may have missed something, some of the names you can basically read about them later on as you do your search for these pioneering researchers. In the area of dynamic programming, the person name who comes up very often is by the name of Richard Bellman. So, Bellman has a very classical book in the area of dynamic programming. So, he was born in 26th August 1920 and died in 19 March 1984. He was an American. So, he was an American applied mathematician who introduced dynamic programming, as I mentioned this classical book. And he worked in the area of in the 1950s and worked and made significant contribution in the areas of field of other mathematics. You can find out dynamic programming would be considered in the area of optimization later on, where resource allocations has to be done as you proceed from one period of time to the other. And along with dynamic programming, if you consider the concept of stochastic programming, it would basically really be very tough and interesting problems, which if solved properly would give you a lot of insight in how the problems are to be solved. So, sources about him can be found in Wikipedia. The next person about whom I will discuss is an Indian by the name of Narendra Krishna Karmakar. He was born in 1975 and he developed a very interesting algorithm known by the Karmakar's interior point algorithm. So, basically it may be the first polynomial time algorithm for linear programming problem, which is basically utilized when you use the concept of trying to find out what is the linear programming solution. All the computer programs which are used nowadays to solve the linear programming and other programmings use this concept of linear interior point algorithm, based on which Karmakar proposed the pioneering work, where the search criteria, how the search criteria can be utilized in order to arrive at the results. Information about him. So, this algorithm is a cornerstone in the field of linear programming and it is utilized very heavily. Information about him, Karmakar, can be found out in the Wikipedia link. Now, generally this I am mentioning as the names, but generally the historical perspective based on for OR actually came up from the environmental factor. Environment means, I do not mean the mother nature, basically based on the fact during World War II, resources have been utilized in the optimal way to basically produce different things. It can be utilized for for producing food for the army, trying to basically utilize them in the best possible manner in the shortest possible time to produce fighting equipments, to transport people, to utilize the land, the sea and so on and so forth in order to optimize whatever you want to do. So, obviously, optimization would be faster transport of human beings, maybe the maximum number of guns which could be produced, or trying to basically minimize the throughput of production for when the ship or this aircraft carriers were being utilized, or you want to basically try to fire the this aircraft tanks, and how this throughput of the tanks can be utilized, how the firing of the tanks could be utilized into maximum possible extent to basically bring the maximum damage for the enemies. So, these I am giving you very simple examples, but the actual background for operational research which came out basically by the demand in nature, by demand of environment, how human beings could utilize that, utilize the resources during the World War II, and based on that all the theoretical what came out which I had mentioned. So, the names which I mentioned are not the end of the list. So, there are different sets of people who are very famous. You can definitely have a look and basically understand how interesting the field is. And my discussion about the World War II is also very brief, but do check about how during World War II operational research has been utilized, and there are very good links in Wikipedia. Study them and that will give you a lot of information. This information does not mean they are anything to do with direct academic thing about how you solve the problem, but they will give you a good flavor of how the story has been built up, such that it will also motivate you to study more about different concepts which you will pick up later on as we proceed with the course. Now, formulating the linear programming, okay, before I go into the formulation, obviously there would be other people coming up in the due discussions. I will mention them as required in the discussions as we consider the concept. So, formulating the linear programming, the ideas would be you need to basically completely understand the managerial problem and what the practical situation is and what is being faced in practicality in the application side. Now, remember one thing, main problem would be to formulate the problem in the right sense, as that based on the assumptions, based on the practicality, we can get the best solution which will give us some hint that what is the best possible solution in the actual practical sense, or when we are trying to basically solve the problem. So, we have to understand the problem to the nitty-gritty, to the barest possible in the least possible way, in the sense that we go into the depth, try to utilize the formulation in the best possible manner and arrive at the results. So, you should identify what is the objective and what are the constraints. So, the constraints would basically mean that what are the decision variables, based on which the decision variable limitation can be less than type, can be greater than type, can be bounded between less than type and greater than type. So, once the decision variables have been identified, we will try to find out that how the decision variables go into the objective functions, how the decision variables go into the constraints. So, whether they are 1 constraint, 2 constraint, 3 constraints, you have to basically understand them accordingly. So, you will use the decision variables to write the mathematical expression. The mathematical expression would be coming out in the objective function and the constraint, but remember one thing, that once I mentioned that they are all linear in nature, the constraints and the objective function would always be linear in nature. So, once you formulate that, you can either solve it in the simplistic sense using the graphical method, and in the higher dimension sense, when you have more than 2 decision variables, we will basically utilize the simple mathematical linear concept or simplex method, and then later go into the dual problem, primal problem in order to solve the simple area of linear programming. So, with this I will end the second class, or which is the second lecture in the first week, and basically try to understand 1 or 2 different examples of different favors, and then proceed with the solutions for the linear programming. Have a nice day and thank you very much.